In this video, we are going to talk about how to calculate the surface area of pyramids. Now, pyramids can have different shaped bases, but the one that we're going to stick to is the basic shape, and that is a square base. Okay, so anytime we talk about a pyramid, it will be referred to as a square base pyramid. So the very bottom of it will be a square, guaranteed, and then we'll talk about the other shapes that are involved in the pyramid. Now, in some of my other classes, I may talk about pentagonal pyramids, or triangular pyramids, or hexagonal pyramids, or other pyramids that don't have a square base. But any shape that you can draw, essentially, can be turned into a pyramid. Now, the new type of idea here, before we get into actually the surface area of a pyramid, because that'll be really the review part, is that pyramids have two different types of heights. There's the actual height, which we will denote with usually a capital H for pyramids, and that is the true actual height. So if you were at the peak of the pyramid and you dropped down Mission Impossible style through the ceiling of the pyramid and landed right in the center of the square base on the bottom, then that distance there is what we would call the true height H. Okay? Like if you saw a pyramid, you should say, hey, or blah, blah. If you saw a real, oh my gosh, if you saw a real pyramid and said, hey, how tall is that pyramid? Then the number that you would hear would be the true height. Now, on the other hand, there's going to be something called the slant height. And the slant height we'll refer to as, most of the time you'll see it as a lowercase cursive L. Okay, so just like a little looped L here. And we don't usually do like a non-cursive L because then it looks like a 1, right? And some people might go, well, why don't we use an S to talk about slant height? Well, S kind of looks like a 5 to some people, so we go with the L, but we make it looped, okay? Now, the slant height really starts at the same spot. You start at the top, but instead of actually going inside the pyramid, we're going to stay on the outside of the pyramid. And what we're going to do is we're going to pick one of the triangular faces of the pyramid, and we're going to slide straight down the middle until we get down to this bottom edge. And you're going to get down here in such a way that you are going to make a 90-degree angle with that slant height. Again, here's the slant height. And then when the slant height meets up with that bottom base edge, that you have made a perpendicular relationship. Okay, so you'll make a 90-degree angle down here. It's also kind of like saying, well, what if I didn't go down the middle? What if I went down like this way? Well, then this wouldn't necessarily be a 90-degree angle here. It would be something bigger or smaller. All right. So slant height is going to be on the outside of the pyramid. The real height's going to be on the inside of the pyramid. And we're going to use both of these types of heights. Really in today's video and in the next video when we talk about the volume of pyramids. So what will we be calculating in terms of the surface area of a pyramid? So I took a pyramid, and imagine if I just I flattened out a pyramid, okay? Imagine it's kind of like a box, and I just open it up and I flatten it out. Then this is something that I could potentially see, right? Here's that bottom square base, and then we have 4 triangles that wrap around and really make up like the walls of the pyramid, right? So when we talk about the surface area of a pyramid, what are we actually going to be calculating? Well, here's what I want you to think of the surface area of a square base pyramid as. It's simply just 4 triangles, and what's going to be nice is each of those 4 triangles are going to have the same area. And we've got 1 square that's right in the middle here. So in the end, you're going to have to calculate 2 things. We're going to have to figure out what is the area of 1 triangle, because if we know the area of 1 triangle, then we can just multiply it by 4 to get all 4 triangles. So that'll take care of the first part. And then we're going to add to that our 1 square in the middle. And areas of squares and triangles were usually pretty easy things to calculate. All right, so we're going to start with a a basic example here. So calculate the surface area. So here's what I always like to start off with. Surface area, SA, equals 4 triangles plus 1 square. And we're just going to kind of plug in what we know into these parts here. All right. Now, the 4 triangles, I've got 4, and then our basic formula for the area of a triangle that we're going to hopefully use every time is going to be either 1/2 base times height or base times height divided by 2. It didn't really matter which one. All right. So I'm just going to use, I always like using 1/2 times base times height. And so do I know the base and the height of each of those 4 triangles? And I actually do. Now, the 10 that's being pointed at here is the slant height of the pyramid, but it's also the height of this triangular wall that's right here. Okay, so the 10, we have to look at it in 2 different ways. The 10 is the slant height to the pyramid, but the 10 is also the the lowercase h height of this triangle. So we know the height is 10. The base has to be perpendicular to the height. So the height and the base have to make a 90-degree angle, and there's our 90-degree angle. So this piece down here would be the base. But how long is that piece? Well, it's going to have to be 9. And why does it have to be 9? Well, what shape did we say that the base of the pyramid would always be? And it's always going to be a square in all the problems that we're going to work on. And what's true about all the side lengths of a square? They're all the same. So we know the base of this triangle is 9, and the height of it is 10. So we'll have 4 triangles, each with 1/2 base times height, 9 times 10, plus we've got 1 square. And what was the area formula for a square? Well, it's just base times height, right? But you got to remember, the base and the height of a square and the base and the height of a triangle could potentially be different values. And it is in this case, right? The base and the height of the square are the same number. And what are the base and the height of the square? Well, it's going to be 9 and 9 is the base and the height. So we're going to add another 9 times 9. Now, we can easily figure out that part. The area of that square on the bottom has an area of 81. And then we can either use our calculator or use some mental math here. So that 4 times 1/2 times 9 times 10. Keep in mind, you are multiplying all 4 of these values together here. So let's see. 9 times 10, that's 90. And 4 times 1/2 is 2. So we're really taking 2 times 90, which is 180. And so 180 for all 4 triangles plus 81 for the square gives us a total surface area of 261. Now the units in this problem are in meters, and area and surface area, doesn't matter which, is always in squared units. So technically this is 261 squared meters, or meters squared. Now, am I going to make a big deal out of putting units on these? Absolutely not. But I just want you to know that that's what the units should be. Whatever the units are, they should be squared units. Okay, so that's the easy problem, because I gave you everything that you needed. You just needed to put it all together to find the surface area. So now let's look at a little bit more, I'm not going to say a tough problem, but something that we're going to have to do a little bit more legwork before we can finally find the surface area. Now, initially you might look at this problem and go, well, this doesn't look any different than the last one. And so I'll go ahead and start off with surface area equals 4 triangles plus 1 square. And I don't know, sometimes I like to start with the 1 square just to knock it out if I know it, right? And if the square down here, we notice that this says 20, well then this side is also 20. So the area of that square is a 20 times 20 square, which is an area of 400. So we already know how much the square is going to be. Now you might go, well, the triangle is going to be just as easy, right? Because we're going to do 1/2, 20. 20 is the base down here. And, you know, if we're looking at and you only really need to look at one triangle, and I always like to look at this, usually this right side of the pyramid triangle. The base is 20 down here, and the height's 24, right? Except that 24 is not the actual height that we need for the triangle. The 24 is pointing to the inside of the pyramid, and it's pointing to, well, let me grab a different color here. The 24 is pointing to the actual height of the pyramid. Now, what we're going to have to do is figure out a way to convert the real height of a pyramid into the slant height of the pyramid, because the slant height of the pyramid is the height of the triangle that we really need here. Okay? And so we're going to use something that we've used not that long ago. So let me kind of clear this off in here. Perfect. And let me draw in the height that we really need. So go straight down the middle here. We need to figure out this. And remember, it's going to be perpendicular down here, but you don't really have to draw on those 90-degree angles. But this has two different names. This is either going to be the slant height of the pyramid, or it's the height of the triangle, the height of the yellow triangle that I have there. Now, what we're going to use to figure that out is we will use this 24. So imagine I've got this 24 right here. And notice that there's this right angle that's kind of standing up inside the pyramid. And it's right up against that real height, that capital H real height of 24. And so there's one extra little piece we're going to have to connect. We're going to connect the bottom of the real height to the bottom of the slant height. And just draw that piece in. And then what I want to draw your attention to is that now we have a right triangle that's standing up inside this pyramid. And the hypotenuse of that right triangle that's standing up is that slant height, or it's the height of the triangle. And so what we are going to end up doing is use some Pythagorean theorem. So we're going to be solving for this in the Pythagorean theorem. We know this side's 24, but how long is this new bottom side here? And so one thing I would say is whenever we drop down the real height to the square base, it is right in the middle of the square base. And the bottom of the slant height goes right to the middle of one of these sides of the square. So if I connect those two things together, being in the middle of the square and in the middle of this side, well then this is exactly half the length of the side of a square. So if the whole length is 20, then this piece down here is going to be half of it, and it's going to be 10. Okay, so you can always do that. Whatever the side length is for your square base, cut it in half, and that's how long this piece is from the bottom of the real height to the bottom of the slant height. Now we can do some Pythagorean theorem. Okay, so I'm going to do this. Let's see, I need some room here. I'll do it off to the side over here, why not? So my slant height, or the height of my triangle, is my hypotenuse because it's opposite the 90-degree angle. So this is the C side. So first let me start off with Pythagorean theorem. C squared equals A squared plus B squared. And we're solving for C, so we're going to leave it alone. Now the A and the B, it didn't matter which one was which. So my two numbers for A and B are going to be 10 and 24. So I'll usually start off with the smaller number first. So 10 squared plus 24 squared. So then C squared equals 10 squared is 100, and 24 squared is 576. And when I add 100 and 576 together, I get 676. But now I've got to square root both sides to get rid of the square on the C, so they cancel each other out. And the square root of 676 comes out to be equal to exactly, I don't know why it's all crazy there, 26. No decimals here. So this number is 26. So that again is the height of the triangular face that we needed to go with our base of 20 down here to find the area of one of our triangles. So now we can finish off the surface area. So we had 4 triangles. Each triangle is going to be 1/2, except that looks like a negative now. There we go. 1/2 times base times, and we just figured out the height of the triangle as being 26. So now We're going to add that to our 400 area of square there. So let's see here. This one's a little bit more mental math here. So this is 2. 2 times 20 is 40. And then 40 times 26 is, let's see, 4 and carry my 2, 10, 40, 1040. And then add 400 onto that. Gives us a full surface area of 1440. And again, if I want to put units, my units are centimeters, and this is always going to be in squared units. So 1440 centimeters squared. Now, at the most part, this is as much work as you'll have to do. For surface area, you need the slant height. But if I give you the real height, you're going to have to use the Pythagorean theorem in order to convert that real height to the slant height. And that's as tough as these problems get for surface area. Okay, you're going to be hoping I give you problems like example 1, where I give you the slant height, and then you can go ahead and plug and chug and figure out what the total surface area is. But every once in a while, I will throw one of these examples like example 2 out, just so that you can practice with kind of persevering through a problem that isn't easy, but at the same time is not overly challenging. All right? So good luck, guys, with your work tomorrow.